All right, so if you want to solve this exponential equation, the first thing I'm going to do is I'm going to divide both sides by 4, because I know 32 can be divided by 4. So if I do that, I'll get 3 to the power of 4x plus 1 equals 32 divided by 4 is just 8, and 5 to the power of 3x minus 2. Now, there's no way I can combine any of these numbers because there's no way to make the bases the same. So now I just have to log both sides to get rid of x in the exponent. So log 3 to the power of 4x plus 1 goes log 8, 5, 3x minus 2. Now, the problem here is I cannot bring the exponent down because there's an 8 inside this bracket. So I need to first use my rules of log to split this up into two different equations. I'm going to write this the exact same. Over here, I'm going to split this into log 8 plus log 5, 3x minus 2. Now I can bring down my exponents. So let me bring down the exponent on this side first. So 4x plus 1 times log 3 equals to log 8 plus 3x minus 2 log 5. At this point, I could actually do this with exact values, but it's going to be very, very complicated. Although not impossible to do it, I'm going to convert it to decimals just because it's a bit easier. Although it's going to be slightly less accurate, your solution is just an estimate. It's not 100% exact. So I'm going to do log 3 in my calculator. And I get 0.477. So 4x plus 1 times 0.477. Log 8 is just 0.903. And log 5 is just 0.699. Again, this step is optional. You could just use the logs and follow the same steps. You would get an exact solution. It's just I find that to be a bit difficult, so I prefer to convert these to decimals. It's going to be a bit easier. Next, I'm going to multiply this number into this bracket, and I'm going to multiply this number into this bracket as well. So 4 times 0.477 is 1.908x. 0.477 times 1 is just 0.477. We'll multiply this number into this bracket. This is 2.097x minus 1.398. Then I'll move like terms to the same side. So I'm going to move this one to this side and this one to this side. So I have 1.908x minus 2.097x equals 0.903 minus 1.398 minus 0.477. I'll combine my like terms. Negative 0.189x equals negative 0.972, and then I'll divide both sides by negative 0.189 to isolate x. And I get my final solution to just be approximately 5.143. Again, if you had to do this with exact values, you would just multiply log 3 into the bracket and not convert it. You'd multiply log 5 into the bracket, not convert it. And you would do the exact same steps as this, except there would just be logs everywhere. and you would just isolate the x and then kind of write it like that as well. Maybe I can show that step actually. I'll show that step right now. So if you don't think this is a good enough answer, I'm going to continue from this step on the bottom over here. So if I multiply log 3 into this bracket, I get 4 log 3x plus log 3. And remember, this x is not being logged. So it's like this 4 log 3x plus log 3 and equals to log 8. And then if I multiply this log 5 into this bracket, I have 3 plus 3 log 5x minus 2 log 5. So this would be the next step with exact values. Then I want to bring the x terms to the same size. So I'm going to do the same thing. 4 log 3x minus 3 log 5x. So I just moved this term to this side. And over here, I'm going to move the log 3 to the other side. So I have log 8 minus 2 log 5 minus log 3. Over here, I'm going to common factor out an x. So I have 4 log 3 minus 3 log 5. This side is just exactly the same. Then I'm just going to divide this on this side to isolate x. X equals to log 8 minus 2 log 5 minus log 3 divided by 4 log 3 minus 3 log 5. If you type this whole equation in your calculator, you should get the exact same answer we got earlier. So let me do it really quick. And as you can see, it's a very similar answer, 5.18, but since there's no rounding, you can tell that this is off by just about 0.02. So if we didn't round it, it would be like 5.158. Or you could leave it like that for an exact solution.